So good morning, everyone, and thanks for the introduction, Akshaya. So without further ado, let me start today's session, which is about Microsoft Azure AI Fundamentals. Okay. So let's go through the agenda of today's meeting. So first, we will understand what is artificial intelligence. Okay. So in short, it is termed as AI. So many in this webinar could have come across this word, but let's understand what is AI in today's session. Next, we will learn what is machine learning and what is deep learning. Okay, so machine learning in short is termed as ML. And then we will see what is data science. Then we will move on to know about the Microsoft Azure's AI capabilities. Then we will know and understand about the Microsoft responsible AI principles. And finally, we will have a demo on one of the AI services of Azure on object classification. Okay, so let me move on to the next slide. So now what would be the learning objectives of this course? So this means what will be the learning, what you will be learning at the end of this session. So at the end of this session, you should be able to clearly distinguish what is AI, what is ML or machine learning, what is deep learning, and what is data science. Okay. Next, you should also be able to understand the capabilities of Microsoft Azure platform. Okay. And you should also understand some of the use cases that you can implement using this AI platform. Okay. You will also understand the principles of designing a responsible AI system. Okay. Finally, we will do a hands-on lab through which you will understand how to access the Azure AI platform. Okay. Okay. So what is artificial intelligence? So in simple terms, it is the ability of the computer to think and act like a human. Okay. So AI can be broadly classified into two categories. So one is the ANI and the other one is AGI. So ANI stands for artificial narrow intelligence and AGI stands for artificial general intelligence. First, let's try to understand what ANI is. So the keyword here is narrow. Okay. See, if a system is able to mimic any one of the abilities of a human, right, and it does it very well, then we will be classifying it as a ANI system. I can give you some examples. You might have come across Apple Siri, Alexa, Google Assistants. These are nothing but voice assistant systems, and they do only one job, and they do it extremely well. That is assisting the users with their voice commands. Okay, so such kind of systems, okay, which can do one thing very extremely well, are called ANI systems. And currently, if you see, all the companies are designing and developing most of the products under the ANI category. Now, other example would be like if there is an AI system to predict the sales of their product in the next quarter. Okay, so that is also one of the example of your ANI system. Okay. The other example could be like you might have come across email spam filters in your Outlook. See, how does the spam filter works? It does only one job. By reading that email, it understands whether it is a spam or it's a proper email. Okay. Some other example would be like your face recognitions, which you might have come across in Facebook. See, automatically your face is being recognized and it auto tags in all your photos. Okay, so these systems do a particular task very well. So those are the ANI systems. Okay, now let's understand what an AGI system is. Here the keyword is general. Okay, see, if a system can mimic all the capabilities of a human, then we call those systems as a AGI system. But for now, we are a long way to achieve this because currently all the projects are based upon ANI systems, and your AGI systems, which could be in the future, could be a combination of multiple ANI systems. Okay. And apart from this, there is also one category which is called ASI, which is artificial super intelligence, which means the system is more intelligent than human. But currently it is an hypothetical concept and we cannot even define what super intelligence means. And that's why I purposefully excluded it from my presentation. Okay. So next, let's see what is machine learning and deep learning. Okay. So machine learning, first let's go with the definition. Okay. So machine learning is a branch of AI in which a computer can automatically learn from previous experience without the need of explicit programming manually. Okay. Now, let's try to understand this definition. Okay. The first thing that we need to understand is machine learning is a branch of AI. Okay. So the AI sits at the top of the hierarchy and ML comes under as a branch or a subset of the AI system. The next keyword that we need to note is previous experience and not explicitly programmed. Okay. So let us try to understand this from an example. So I hope most of us are using OTT platforms like Netflix, Amazon Prime, or music apps like Spotify, Amazon Music, or Ghana. So in these systems, if you have carefully noticed, after a period of time, you could have seen that it starts recommending you movies or songs. Okay, and the technology behind this is nothing but machine learning systems. They have designed and deployed systems to do these recommendations. Okay, so what it does, it analyzes your past data or from your previous experience. So, do you think that someone in Netflix has programmed a query like let or Netflix or let's say in Spotify, like there is no programmer who is coding like the category equal to melody, language equal to English, then recommends songs in which category is equal to melody, language equal to English, and status equal to, let's say, never heard by the user. So no one is programming such things actually, okay? Because it cannot be achieved by manual programming at all, these recommendations. If the user is going to hear another genre, let's say he's going to hear a rock music or a dance music, the programmer cannot be adding this in a daily way or in a sequential way. And this will not be practically possible as well. See, that is why we have the term explicitly programming is not required, manually is not required. Okay. And there are a set of algorithms that the system uses and it learns by itself. Okay. And we don't have to program it manually. So that is the key definition of a machine learning. Okay. If you come across any company, let's say they are including conditions in the program by a developer to recommend systems for recommendation of products or songs or movies, then they are not AI or ML systems. Okay, they are just plain rule-based programming outputs. Okay, ML systems, they learn from previous experience without explicit programming. So that is a key term over here. Okay, so some of the examples are like, as I mentioned, music and product recommendations in Amazon or Flipkart. You might have seen some product recommendation. And you can also use it for medical report analysis. Like you can provide some reports based upon your test results. It can mention whether the patient has diabetic or any other ailment. And it can be also used for speech translations. Now let's try to understand uh, what is deep learning. First, let's go with the definition of deep learning. So deep learning is a subset of machine learning that use neural networks modeled after the structure and function of the human brain to complete tasks or make decisions. Okay. Now, here, the first keyword which need focus is deep learning is a subset of machine learning. So the hierarchy is like this. First, we have got AI, then we have got ML. Underneath comes the deep learning. Okay. Next keyword we need to understand is neural networks. So what do you mean by neural networks? So I think we need to just go a few years back when we were in school. We could have learned a few things about our brain. So in our brain, we have got something called neurons, and there are billions of neurons in a person's brain. So these billions of neurons are interconnected. That's how our brain works, and they pass information between the neurons to make a decision. So that's how our brain works. So we have started building systems with the similar fashion, where multiple neurons are built and the neurons communicate between each other to provide a result or prediction or a AI, whatever is the desired output. So we have started building our such systems. I can give you some simple example for this. Okay. Let's say we are going to build a system which is going to recommend a trip. See, some of the let's say if you are going for a trip, what would be your key parameters? One would be your balance in your bank account. Let's say that is your parameter one. Okay. Second is the flight availability. You are planning to go for an abroad trip, let's say. The flight cost, the hotel availability, the hotel cost, the your holiday calendars, because you can have some constraint. You would be a working professional, so you can't go on a working day. So let's have the holiday calendar as one of the constraint. And the other weather condition, let's say the wind, the temperature, the rain forecast, and the visa processing time as well. Okay. So these are some of the parameters that we might have considered. Okay. So now let's say that we build one neuron from the cost perspective. Okay. One neuron to just give the result from a cost perspective. So for this, the factors that will be considered are your bank balance, your flight cost, and your hotel cost. So let's say this is a neuron number one, and this is the one. And the next neuron is the from the availability perspective. Let's say we consider the factors like holiday, the flight availability, the hotel availability, and of course the visa processing time. And let's say we have a third neuron for the climate conditions. Let's say the wind, the temperature, the rain forecast are being like calculated for the best results in the third neuron. Okay, so we have got three different neurons. Okay, individual neurons, and each neuron's result could be connected to a end neuron. Okay, through which you can publish or you can do a trip recommendations. So I hope you understand this. So we can build multiple networks, and building such multiple networks gives you more appropriate results, what you expect from your AI systems. So that is what deep learning means. And this is the exact way our human brains works as well. Okay. See, another example is a driverless car. We have could have seen about Tesla. So it is not a single component. They have a neural network of multiple neurons through which the car makes decision on when to slow down or when to rise up or when to brake. Okay. So that's it for the deep learning. So finally, let's try to understand what is data science. So first, let's go by a short definition. So in short, data science is the process to acquire meaningful insights from the data. Okay. So it's a blend of multiple things, that is statistics, mathematics, programming, and domain knowledge. Okay. So let's try to understand this from an example as well. Okay. So uh, let's say that we want to have a system, okay, to predict the sales of your, let's say you have an electric vehicle bike company, you want to predict the sales in the next quarter. Okay. And you have got multiple details, let's say the uh, showroom wise sales details, the cc of bike, battery capacity, the marketing cost spent on that particular model, service cost, many others, I mean raw data. Okay. If you give these details to a developer who knows only programming, do you think he will be able to predict? Definitely not, because he needs to have some understanding of the business knowledge to make a meaningful insight to the company, which can make a decision on their next sales prediction. Okay. So that is the first thing. So the person who is going to be associated with data science or data scientist needs to know about the domain knowledge, how the domain works. Okay. It is not only the domain knowledge, the person needs to understand some concepts of statistics, okay, which in turn implies that he should be good at mathematics and algorithms as well. Okay. So the data scientists, they have a lot of algorithms. The correct algorithm should be derived by the data scientist. So they should have knowledge about these two fields as well. Okay. And finally, they should also have a understanding of programming as well, because they would be executing different programs and trying to build models, okay, for what can provide a meaningful insight for the company to predict the sales, or based upon the sales, they can actually do the manufacturing plan and everything. Okay. So if the person can do or perform all these activities, they are called a data scientist. And currently, this is one of the most top paying jobs. Okay. So the reason for this is like there's a mix and match of multiple skills which is required. Okay. So that's why predicting demand as an example. The other example can be for insurance claims. Okay. So you can build an AI system to automatically approve or reject insurance claims. So that needs a blend of all these skills. Okay, fine. Okay. So now so in this picture, so you can see that there is an AI. So this is just a summary of what we have learned in the previous few slides. So AI stands at the top of the umbrella. So inside that we have got machine learning or the ML. Inside that we have the deep learning component. And data science, as I mentioned, it's a mix and match of many skills. So you need to know a little bit of mathematics and statistics, the domain knowledge and programming, and all this as well. Okay. That's why this skill is highly rated currently. Good. So now let's move on to understand the capabilities of Microsoft Azure AI. Okay. And they are, let's say, first would be the machine learning. Okay. Second is anomaly detection. Third is computer vision. The fourth is natural language processing. And the fifth one is the conversational AI. I'll quickly go through with one example in the benefit of time. Okay. So in machine learning, we have got different types of machine learning. Okay. So the first category would be supervised machine learning. So what does it mean? In supervised learning, we as a users, we will provide the data to the system. Okay. So we will provide this picture and we will say this is apple. We will provide this picture and we will say this is banana. We will provide this and we will say this is watermelon. Okay. So these apples, banana, watermelon are called tags. Okay. So, and we train this model not with one picture. We might be providing with many pictures actually of apple, many pictures of banana, many pictures of watermelon. Today we will see a demo on this. Okay. So anyway, I'll be showcasing this. Okay. So if you train the model and if you just provide this as the test input, then it will predict that, okay, this is a banana. So that is what supervised learning is. We train the model with the data we provide. Next, let's see what is unsupervised learning. Okay, I will try to explain this with an example. Suppose if I provide this image to the AI system, which is having an unsupervised learning, okay, it will classify the image or the objects in the image based upon some common traits. Let's say it can be shape, it can be color, it can be similar patterns. Okay. But please understand that the system cannot understand this is a cat and this is a dog. Okay. It cannot understand that, but it can understand that this is category 1. Okay. Because these objects in the picture have some similar categories. The ears, okay, they have some the nose are similar, so it can predict, okay, this is category 1, but it cannot say that this is a cat. Okay. Similarly, it can predict this as category B. Okay, because these images or objects have a similar traits. Okay. Finally, like the image, the system might not be able to categorize this as A or B, so it might categorize this as category C. See, so here we are not providing as a user any inputs like the previous example, but without any supervision, the system themselves learn and categorize it accordingly. So that's an unsupervised machine learning system. The last one is the machine learning using the reinforcement learning. Okay. If you ever got pets in home, you can relate to this. So I have got 2 pet dogs, and during the initial stages, when we train the dogs, we reward them for good behavior. For example, if they obeyed our command, we used to provide them treats or biscuits. Okay. So their brain relates to the activity to reward. So they learn to obey our commands. Okay. Likewise, we don't reward them for bad behaviors, like if they are biting the shoes or clothes in the young age. Okay, so we don't reward them. So through this, they learn that they we if we do an activity, we will be rewarded, and if we do another activity, we will not be rewarded. So this reward system, they grew up and they become more disciplined pets. In the same way, we can also create AI systems. That's an interesting use case. Like a few years back, like a system was created which was called AlphaGo. Okay, so Go is nothing but it's a board game. So which originated in China more than 2000 years back, and a company called DeepMind built a system called AlphaGo. Okay, and they use this reinforcement learning technique, and after a few months, AlphaGo was able to beat the 18 times Go world champion in Korea with a score of 4-1. Totally 5 games were played, in which 4 was won by AlphaGo, only one by the 18-time world champion. Okay, so that's an excellent documentary available in YouTube for 90 minutes on this as well. You can go check it if you over a weekend as well. So that's what a reinforcement training means. Okay, now let's try to cover the next AI capabilities of Azure, which is anomaly detection. Okay, so this capability is used to detect unusual events or patterns. Okay, so I can give an example. So let's say we have like I have a credit card and I usually pay internet bills or mobile recharge, electricity bills, which are only around 1,000 to 3,000 rupees. Okay, but if I made a sudden purchase of let's say 2 lakhs, okay, in some jewelry shop, this is an unusual pattern because it was never used. Then this could have triggered an alert to the banking system. And if you have experienced this, there could be some calls coming from your bank's customer care just to verify if it is a valid transaction performed by you. I'm not sure, like I have experienced that. So the system behind this is an anomaly detection that we have in Microsoft Azure. A similar system might have been deployed over there. Okay. See, another example could be your application login. Let's say you are logging into your application, let's say your Gmail system, okay, or some other system, any web application. So throughout the year, from a location, let's say India, okay, and suddenly you one day the IP that you log in from is like Spain or Russia, okay. So now the system can automatically detect this unusual pattern, okay, and we can also perform some actions. Let's say we want to immediately disable this user to further prevent any hacking into the system. We can perform this as well with the use of this anomaly detection capabilities in Microsoft Azure.